हेलो मेरा बच्चा लोग, हाउ आर यू ऑल डूइंग? कैसे है मेरा प्यारा बच्चा लोग? सब ठीक है ना? सब अच्छे कर रहा है? आई होप एवरी वन इज डूइंग सो गुड. So now I want to hear the same from you all. So I'm going to look into the chat box. जल्दी से जल्दी फटाफट बता दीजिए that you all are doing so great and are having a wonderful day. Everyone, so Preeti, hi Sam. Hi Myara, good evening. Sugamana, I'm doing so good. Then who all we have? Then Deepshika, Sam, Myara, Thanmay. A big hi to every bacha logs in the classroom. Hi Palak, good to have you back. Chotu sis. Okay, so my Chotu sister is back here. Hi Mom's Queen. So a big hi to every bacha logs and every warriors in the classroom. So you all know why we are here, right? So in today's class, we'll be having the second lecture of the chapter of properties of solids, where we'll be discussing about the stress strain curve, right? We'll also be discussing about different types of modulus of elasticity. Lot many questions we are going to do. So we have so much in our bucket. So we'll be doing everything step by understanding all the concepts in today's class, right? So yes, whoever is seeing me for the very first time, this is your Ameer sir, your physics educator at Unacademy. And those who love me more, right, instead of calling me Ameer sir, they call me Ameer Bhaiya, है ना? But chalo, a bit of introduction about myself. You all can see on the screen. What is it? I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. I am a beta graduate from NIT Calicut and I taught mentored many students, and here I am Bachalu. Ek aur baat. I am from Kerala, so I have I don't know Hindi much, ठीक है? So I'll be telling in all the classes, right? So whoever is coming expecting Hindi a lot, right? I'll be delivering most of the concepts in English, ठीक है? Okay, now, bachcha log, this is our schedule for this particular week. Here we are on 23rd of November, where we'll be doing mechanical properties of solids part 2. So we are having part 3 and part 4 on the next 2 consecutive days. And on 26th, which will be on Friday, we'll be having the mega Menti quiz from this particular chapter. Let's see who all are going to learn this chapter thoroughly and going to be on top of the leaderboard. ठीक है? Okay. So if you don't want to miss the live classes from your favorite teachers, don't forget to be a part of the Telegram channel. The link is given here and also in the description box. Okay. So yes. Bugs Foundy kya hai chalo? It's an amazing way which will help you to get lot many prizes. You just have to go to the description. Then there you'll find a form and fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. So if it is valid, बहुत सारे prizes आ जाएगा आप सब लोगों का घर पे. But still, is there anyone who haven't tried for the Combat Scholarship Test, which happens on every Sunday at 1 p.m. right? Because you are missing lot many things, bachalo. For the first 25 rankers, certificate of merit from Unacademy is given. It's an amazing thing. Then, for the first rank 3, right? For first 3 rankers, right? 1 year of free Unacademy plus subscription is given. That is also amazing. For other ranks also, you are given so much of amazing scholarship. And the most beautiful thing about the scholarship test is that it's completely free. Free of cost, you don't have to pay anything, but you just have to remember ये code. Code क्या होता है? AMBTET. So use this code, ठीक है, and get into the scholarship test completely for free. Moving on. But chalo, Mom's Queen, Desi, Shankamitra, Preeti, everyone in the classroom, can I give you a small task? The task is this, which I'll be telling in all the classes. Just share the class to all your friends and ask every one of them to join the class as soon as possible. Jaldi se. Right, Myara, Preeti, Crazy? Okay. In the meanwhile, whoever is new to this Unacademy platform, I'll just give a brief introduction about this Unacademy Plus subscription. Now, why do you need to take Unacademy Plus subscription? Because nowadays everything is available in YouTube. Many of you are depending on YouTube for your study purpose. It's a very good thing. It's an amazing thing. I do appreciate every one of you. The only problem with learning with YouTube is like, though everything is available, right, the information is a bit scattered here and there. So it will take some time for you to arrange everything in order and to start learning. If you want to save all those time, okay, and to start and to use all those time for your learning process, the Unacademy Plus subscription is the best thing. Because in the Plus subscription, Anna, we all educators will be teaching you with a proper schedule, bacha log, targeting JEE, NEET board examinations. We'll also make sure that every topic that we'll be covering, it will be in a proper order and will be available to you in that same order. So everything becomes in a proper order. क्या हो जाएगा बच्चा लोग? Yes, that process of learning becomes so simple. You will start loving, right, the process of learning. Then you'll start giving lot much amount of time. You will start giving more effort, right, in a very smart way. The progress that you'll be making will be so immense that I can guarantee you as your educator. One thing. Then top educators of the country who's having a very good experience will be there to teach you. ठीक है, they'll be telling you what to study, what not to study, ठीक है, and they'll also be telling you what are the multiple choice questions as you should be practicing. You just follow them, okay? You'll be getting a very good mark for all the competitive examinations, yes, and we will be ending up in the colleges wherever you want to. Then study materials, practice test, live test series will make you what? Super confident bacha log. So as we are almost at the academic year end, 6 month subscription is more than enough, I suppose, according to me. So it will cost you 1,667 per month. And use the code of AMB10, get 10% of extra discount and what? Yes. And maximum offers while you make the subscription. Okay, don't forget the code because I don't think you really want to miss that 10% of discount. It's an amazing thing. It's a huge thing, right? Okay. Then, iconic subscription. You'll get all the features of play, some extra features, bacha log, just as personal mentorship. A person will be assigned to you. He'll be telling you what to study, what not to study, right? Okay, he'll be there just like a friend, right? And for all your academic activities, this person will be there. Okay? Then live doubt solving classes, weekly reports. For all these features, if you're going for a 6 month subscription, it will cost you 2,833 per month. And those who love discount, I think everybody loves discount, right? Use the code of AMB10, get 10% of discount. और क्या करना है? हाँ, and be a part of an academy family. किसको wait कर रहे हैं आप लोग? देख ले what is happening बच्चा लोग. So in the Unacademy, even if you ask doubts है ना, what you're gonna get? Surprise boxes every day. Oh my god! For one doubt, you will be given surprise box from Unacademy. मतलब your doubt will also be solved at the same time. A surprise gift box will also be delivered to you. वाह. For 10 doubts, if you're asking 10 doubts and और कुछ नहीं करना है आप लोगों को, you just have to 10 doubts, clear your 10 doubts, and 15 days Unacademy free subscription is also given. Just ask now. This is only valid till 28th of November. It is completely free. Those who haven't downloaded the app till now, जल्दी से download कर ले, and to unlock this particular app, use the code of AMB10 and unlock and start learning. ठीक है? So बच्चा लोग, शाहत, Desi, Mom's Queen, Chaturvedi, Preeti, Shruti, Crazy Isha, everyone. It's time for our physics. Yes, let's start the class. I was about to ask you, are you all ready for the classes to get started? Just tell me that. If you all are ready, nothing is going to stop us. We'll be starting right away, right now. Miara, let's crack it. Crazy Isha is like, yes sir, bilkul. Let's start. Full energy. Bhumika, good evening. Okay, Preeti, Miara, Sam, Purna. Okay, so everybody is super ready. So let's get started. Right? Okay. Now, tell me, or instead of just telling me also, you can just revise in your own mind. Tell me what are the topics we have covered in yesterday's class. What all topics we have covered in yesterday's class? We have started the chapter. We talked about elasticity. Then we came to the topic of stress. We have discussed 3 different types of stress. Then we talked about strain. We talked about 3 different types of strain. Then we talked about Hooke's law. How many of you do remember? Right, Hooke's law tells stress is directly proportional to strain within the elastic limit. है ना? And that stress by strain is equal to a constant. We call it as modulus of elasticity, isn't it? It was still here, bacha log. We have did our explanation in yesterday's class. So yes, let's continue from there. Now, everybody take out your Chotu notebook, okay, and write down the topic. नाम क्या है आज का टॉपिक का? पहला टॉपिक है the stress strain curve. Matlab, here we are going to discuss, right, a graph which is plotted between the stress and the strain. Shall we? Yes? Okay, so I think everybody took your Chotu notebook, Sankamitra, Shreya, everyone. Okay, now first I'll explain you how this particular graph was attained, right? Then we will look into this graph, okay, very thoroughly. देख ले. Okay. Let's say you are having a body of length L in your hand. ठीक है? So scientists actually took, okay, a body of length L in their hand. Okay, क्या किया उसके बाद? They started to apply the force on the body. Equal and opposite forces was applied on the body. What will happen? The body will start stretching. So along with the body start stretching, what will happen? Yes, the stress will be produced inside the body, and the amount of strain will also be produced, isn't it? So for every value of stress, right, for every value of stress, the stress strain value was also noted down and it was plotted in the graph. So when the stress value was found to be this much, yes, the strain value was found to be this much. Then again you started increasing the external force, measured the value of stress, right, plotted in the graph, okay, and measured the value of strain at the moment, plotted in the graph. So a graph was obtained if you have plotted the value of stress and strain at each and every point on that particular body. And here we are having a general stress strain graph which can be used for explaining the property of everything, right? Okay, so shall we explain this experimental stress strain curve? This is very important for understanding the property of any material. ठीक है? Okay, yes. Is it clear? Okay. Net force is only 0 मेरा बच्चा. Initially when you are applying, देख ले, at this particular end, right, the force is not 0, right? So the body will start developing the restoring force. The body will stop stretching once the external force is equal to the restoring force. Till then only the body stretches, right? The stretching stops once the external force is equal to the restoring force. ठीक है? Okay. Now देख ले, look into the graph. Initially when the stress and the strain was plotted in this particular graph, what did you obtain? You can see that there was a straight line was obtained between the stress and the strain curve. Can you see that? Stress is plotted on the y-axis, strain is plotted on the x-axis. So it is a straight line till the point A. Tell me, if there is a straight line existing between the stress strain curve, what can you tell about the stress strain curve till that point? From O to A, what can you tell, mera bachcha log? What can you tell? Yes, from O to A, the stress value is directly proportional to strain. If it is directly proportional, which law is being satisfied by that particular material? Yes, Hooke's law. Very important, everybody take down the note along with me. So from 0 to A, where the stress is directly proportional to strain, right, the Hooke's law is being satisfied. One thing. Second, first point is written, है ना? So the second point मेरे बच्चा लोग देख लें. The second point in the region of 0 to A is the body will be acting completely elastic. Elastic का मतलब क्या है? Once we remove that external deforming force, the body will be regaining its original shape. So these are the properties. Very good. So Vishnunath, then Connor, Shreya, everybody is giving the answer. Bhumika, yes, it's about Hooke's law. Okay, so 0 to A region, right, all these properties are satisfied. Matlab, the stress is directly proportional to strain. Okay, Hooke's law is valid there, and the body will be completely acting elastic in this particular region. Okay, everybody written down this. It's very important. Okay, now can I tell you one more point to this particular region? ये point है ना, this point A, we call it as the proportional limit. What do you call the point A as? We call the point A as proportional limit. कोई reason है क्या? Yes, because it is till this particular point, right, the stress is directly proportional to strain. It is till that particular point the Hooke's law is valid. That's why we have this point with the name of proportional limit. ठीक है? So written down everything. I want all these 3 points in your notebook, right? Along with the graph where A is marked with the proportional limit. Okay. Clear? Noted. Okay. Now, on this particular body which we were discussing, ये body है ना, again I started to increase the deforming force. क्या हो जाएगा? The stress will increase, right? And the strain was also found to be increasing. But if you look to the region of A to B, it is not a straight line. Okay, matlab the stress is not directly proportional to strain. So I'll write it here. From the region of B to C, write stress not proportional, everybody, to strain. But though it is not proportional, right, in that region still the body will be acting as an elastic body. Matlab kya hai? From this particular graph, even though the body enters into the region of A to B, right, the body will be acting elastic. Matlab, if you remove the deforming force, the body will be coming back to its original position. ठीक है? So that is the speciality of the point A to B. ठीक है? So the maximum point till which the body will be acting as an elastic body, we call this point as yield point, or also with the name of elastic limit. The maximum point till which the body will be acting elastic, we call it with the name of elastic limit or yield point. It is very important. Is it clear? Okay, yes, the body will be having elastic deformation. Matlab, it will be coming back to its original position. ठीक है ना? ठीक है? Okay, yes, Sankamitra, Shruti, Nancy. Okay, so I hope everybody have written down, right? So we are not still going to stop the stretching of this body. क्या करेगा? What are we going to do? Yes, I am going to apply the force again on the body. The stress will again increase. The strain will again increase. The graph was plotted. देख ले, when the graph was plotted from B to D, you are getting a graph like this. Okay, एक ऐसा graph मिल गया हमको. Now, if you look into the points, है ना, from B to D, if you look into the points, okay, take some random point in between from B to this particular point, right? If you look into the increase of the stress from the point B, let's say I'm calling this particular point as Z, okay? If you look the point from B to Z, you can see that if you move from the point B to Z, the increase in its stress, the stress is plotted on the y-axis, अच्छे से देख ले. The increase in stress is not that huge, but if you look at the increase in the strain, if you move from the point B to Z, it is so huge. So B to D is a region where the increase in stress is lesser, but there will be a huge increase in strain, 1 point. If you want, I can write it down. So B to D, yes, B to D is a point. B to D is a point, right? Stress, okay, increase will be less, okay. At the same time, the increase of strain will be very more, okay. The very first point, you can consider this as one single point. ठीक है? Now, अगला point देख ले. From B to D, what you can say? Is the body going to act as elastic from B to D? बिल्कुल नहीं. From the point B to D, you can see that the body will be acting completely plastic. Matlab, if you remove the deforming force, the body will not be coming back to its original position. ठीक है मेरा अच्छा लोग? So, from B to D, the body will be acting completely plastic. This is very important. This is very important. Write it down. The body will be acting like completely plastic. Matlab, even if you remove the external force, the strain will not be zero because there will be still extension in that body. Understood? Though the stress that you apply is zero, right? Even if you are not applying any external force on the body will not be coming back to its original position. Matlab, though the stress is zero, the strain will not be 0. Why? Because the body is not coming back to its original position. So बिल्कुल से बिल्कुल strain should not be 0. ठीक है? Is it clear? Okay. Now, as the body does not come back to its original position, we can say that the body has attained a permanent set. Why we give the name as a permanent set to the body? Because body is not coming back. Okay, whatever is its new shape, it is going to be in that shape itself. समझ में आ गया? Is it clear? Okay. So these are the important points of the region B to D. Done? Okay, B to D is a plastic region, right? Okay, the increase in stress is less compared to the increase in strain. Second point, right? Okay, so the body will be attaining, yes, a permanent set there because it is a plastic region. Clear? So these are the important points that you have to keep in mind regarding the region of B to D. Okay, yes, and ये point D है ना, ये point D we call it as ultimate tensile strength. Mark it down. Ultimate tensile strength. Okay, the point till where there is an increase of stress and strain. That is the point till where there is an increase of stress or strain, right? Both stress and strain are increasing at the same time. It happens only till the point D, and that maximum point we call it with the name of ultimate tensile strength. Is it clear? Got it? Okay, now देख ले the last part D to E. From again देख ले हमारा example, that particular body again you are expanding by applying external force. Okay, again expand कर रहे हैं आप लोग, so stress will be increasing and strain will be increasing है ना. But you can see that from D to E, though the value of stress strain is increasing from D to E, you can see that the strain is increasing, but what is happening to the stress? Stress is found to be decreasing from the point D to E, and the point E, what happens? It breaks, and so the point E we call it by the name of fracture point. E का नाम क्या है? What is the name given to the point E? Fracture point Q, because at that point if the body reaches, it breaks. ठीक है? It is completely experimental. ये experimental graph होता है. This is not theoretical. That's why I was telling you. देख ले, I was taking a body, applying external force, stress will be produced, corresponding strain will also be produced. That is being plotted in the graph. So for every point was plotted in the graph, this is the shape of a graph that was given by a general body. Okay. Now, can I ask you a small question, bachcha log? Can I ask you a small question? Can I ask you a small question? Sun le. Okay. Now, if the portion D to E hai na, can you see the portion D to E? Can you see that portion D to E? If that D to E portion is very much larger, what kind of body will be having? Whether it is going to be a brittle body or whether it is going to be a ductile body. I hope you all know what do you mean by brittle and ductile. जल्दी से बोल दे. Tell me what kind of body will be having if the D to E region is larger. D to E region, if it is larger, we will be having ductile body. Very good, Purna. Okay. What do you mean by ductile material? Right, those doesn't break very easily. मतलब देख ले, if these two points are so close to each other, body will be breaking ऐसे because that region is chotu. If it is very much larger, right, a huge amount of strain has to be produced in the body for it to break. समझ में आ गया? So if that DE region is larger, okay, the body will be ductile material. I hope you understood what do you mean by ductile material. Those which will not be breaking easily, right? Those material which we can apply some forces and convert it into different shapes. Okay, those materials are called as ductile materials. So shall I write it there? DE region, right? DE region, if larger, we will be having what kind of material? We'll be having ductile material. Okay? And if it is smaller, what kind of material will be having, bachcha log? Yes, we'll be having brittle. Brittle matlab those material which breaks so easily. Clear? Is it clear, mera bachcha log? Okay, done. Okay, so समझ में आ गया. Is this particular graph is clear to everyone? Is this graph clear to everyone? Okay, perfect. Yes, clear. So I forgot to define one single point here. Do you remember this elastic point? The point till where the body is found to be elastic, right? If you measure the stress at that point, Anna, if you are measuring the stress at that particular point, that stress we call it by the name of yield stress. What is yield stress, right? If you are measuring the value of stress at the elastic limit or at the yield point, that stress we call it as the yield stress. Or another definition if you want, yield stress, okay, is the maximum value of stress till which the body will be acting elastic in nature. Once again, yield stress, those who want to write it down, I'll go slowly. Yield stress is the value of stress till where the body, okay, will be acting elastic in nature. So now perfect, I suppose. Hana, whatever questions come from this part of stress strain curve, you'll be like, we are going to give the answer. Isn't it? Yes, got it, Shraddha? Point to be noted, है ना? Okay. So अब हम क्या करने जा रहे हैं? Yes, we're gonna do a question. एक two question है इधर. Can you see the question, मेरा बच्चा लोग? Yes, okay. A stress strain curve is given here, right? Okay, two graphs are there. One graph is P, okay. दूसरा graph है हमारा Q. But how many of you have noted a difference here? Is there any difference here from the graph which we have learned? Okay, is there any difference from the graph which we have learned? Anyone? हाँ, देख ले. Here the stress is plotted on the x-axis and the strain is plotted on the y-axis. That's a difference, right? Okay. Now, looking into the graph, tell me, right, which one is having a greater modulus of elasticity, right? Which one is having greater, right, modulus of elasticity K, whether it is P or whether it is Q? Tell me in the chat box. I am looking in the chat box. The one which is having greater modulus of elasticity. Don't just jump into the answer, right? Look the graph properly. Then find how you can find out the modulus of elasticity from here, right? Then give the answer. Sankamitra बोल रहा है कि P है, Q है, right? Shruti with Q, Eden with Q. Then Arpan P बोल रहा है, Abhimanyu P बोल रहा है, Bhumika P बोल रहा है, Preeti P बोल रहा है. Either now you have changed to P, है ना? Okay. Now I think many of you are going with the option of P here, right? Which means it is the body P, right, which is having a greater modulus of elasticity. बिल्कुल बढ़िया मेरा बच्चा लोग. चाहत, भूमिका, म्यारा, very good. Yes, you all are correct. So first, we'll go step by step, है ना? देख ले. What is the formula for modulus of elasticity? We have learned that is stress divided by strain. So in order to compare the value of modulus of elasticity for the material P and Q, let's see how we can obtain the value of stress by strain from the graph. देख ले. If you mark this as theta, right, what will tan theta be acting as, बच्चा लोग? It will be acting as the slope of the graph, है ना? Tell me, if you find the slope of the graph, what it is going to be? Converting this into a right angle triangle and taking tan theta, what is tan theta going to be? Tan theta is opposite, right? What do we have on the opposite side? This length will be corresponding to that value along the y-axis. What do we have on the y-axis? Strain divided by adjacent side, that value on the x-axis, stress. Strain by stress क्या होता है? अरे it is the inverse of what? The modulus of elasticity. So you can write it as 1 by k. मतलब the slope of the graph is actually giving the inverse of modulus of elasticity, है ना? So tell me the one which is having greater modulus of elasticity, right? How its slope gonna be? Slope क्या हो जाएगा? Will it be larger or higher? अरे they are having inverse relationship, है ना? देख ले, look into the graph. You only tell me. So the one which is having larger modulus of elasticity will be having chotu slope. Which one is having chotu slope? P or Q? P. मिल गया, इतना ही है. मिल गया, हम तो मिल गया, आंसर तो मिल गया. इससे क्या ज्यादा है? तो खुश हो गया आप? Okay, done. Yes, okay, so I hope everybody is happy, है ना? और क्या? Now, ready है क्या? थोड़ा और पढ़ने के लिए आ गया तो आ गया, समझ तो आ गया अभिमन्यु? और क्या और क्या और क्या? बिल्कुल समझ आ गया तो बिल्कुल बढ़िया. Okay, with a smile. अरे बाप रे. So shall we learn bit more of concept? Because after learning the next concept, we have lot much of problems waiting for us. Okay, because it is from the next topic onwards, we'll be having lot many numericals. So let's start doing it. Okay, क्यों wait करना है? What is it? We have learned about what? Yes, modulus of elasticity. Now we are going to discuss about, yes, the different types of modulus of elasticity. Okay, different types of modulus of elasticity is what we are going to learn. Actually, there will be 3 different types of modulus of elasticity. Let's go one by one. Ready? Okay, so yes, here we go with the very first one. Naam kya hai? What is the name given to the first modulus of elasticity? Young's. Okay, chota wala. Okay, young matlab bahut young wala. So we have the Young's modulus of elasticity with the symbol of y. क्या होता है? Modulus of elasticity क्या होता है? That is equal to stress divided by strain. But when we talk about the longitudinal stress divided by longitudinal strain, right, specifically, that modulus of elasticity का नाम है Young's modulus. समझ में आ गया? When we specifically talk about longitudinal stress by longitudinal strain, I think you all do remember ये longitudinal stress and longitudinal strain क्या होता है? अरे the stress produced whenever there is a change in length on the body. देख ले, we are having a string. On that, I am going to hang a body of mass m. What will happen? The mass m will start pulling the string, right? The string will be stretched. Do you remember? A stress is produced here. What do you call the stress? इधर एक stress produce कर रहा है ना बच्चा लोग. Stress का नाम क्या होता है इधर? In the case of change in length, आप ही बोल दे. I'm not going to answer. I'm not going to answer. It's your duty to tell me. What do we call the stress produced here whenever there is a change in length in the body? Answer कुछ भी नहीं. हाँ, longitudinal stress, isn't it? What is the name given to the strain here? Longitudinal strain, right? So that longitudinal stress divided by that longitudinal strain, we call it by the name of Young's modulus of elasticity. ठीक है? So Young's modulus of elasticity is longitudinal stress divided by longitudinal strain होता है. ठीक है? Longitudinal stress का formula थोड़ा और expand कर सकता है. Longitudinal stress everybody know, force by area. Longitudinal strain क्या होता है? Change in length to its original length. Again rearrange. ये by L है ना, वो ऊपर जाएगा. It will go up. So FL divided by A delta L. मिल गया तो मिल गया. That is equal to Young's modulus. So the final formula for Young's modulus, everybody write it down. FL divided by A delta L. Clear? Is it something so hard to understand? Is it something so hard to by heart? बिल्कुल नहीं. It's a very simple concept which everybody can understand, right? Write it down jaldi se. Let's do some problems. let's start doing some problems. If we have time, we'll start with Poisson's law also, Miara. Don't worry, we'll go with all the topics. ठीक है? Noted? Noted, Preeti? Okay. So damn easy. Okay. So we'll do some questions and understand this concept in a better way. Okay. So here we have the question. Question तो आ गया अपन, question आ गया. So the question is all yours. आप ही कर ले. आप ही कर ले. Give me the answer. अरे all the modulus we will discuss. ठीक है? You don't have to worry about anything. We are going to discuss every modulus of elasticity. सब है ना, we'll do. परेशान होने का भी बात नहीं है. तो give me the answer for this. ओके आंसर क्या है इसका? इज इट ऑप्शन ए, बी होता है, सी होता है और डी होता है? प्रीति बोल रहा है कि सर सी ऑप्शन करेक्ट है, 1:8 बोल रहा है वो. ओके फिर जशनदीप बी बोल रहा है. ओके देन श्रद्धा इज गिविंग मी ऑप्शन बी, म्यारा इज लाइक सी. ओके देन हु ऑल आर देयर? Miara C, Arpan D. Okay, so we have a mix of options. Instead of me giving you the answer, shall we do it and find the answer which one it is? Shall we find out? Everyone? Okay. Listen. Everyone, here we go. The ratio of length of two wires A and B of same material is. Tell me, if the material is same, which quantity is going to be constant? Yes, the Young's modulus of the body A and B are going to be a constant, because this Young's modulus it totally depends on the material. If I forgot to tell you at that point of time, now I'm telling you, write it down. Young's modulus of elasticity, that constant, right? Okay, this totally depends upon the material what we are using. So as both are having the same material, what can we write? With a smile, ऐसे ही आपको लिख सकता है that Young's modulus of A and Young's modulus of B equal होता है. Okay, what else is given? The ratio of length of A to the length of B is given as 1:2. Write it down. Then the ratio of their diameters, so the diameter of A to the diameter of B is given as 2/1. Okay, देख ले, they are stretched by the same force. So the force in A and the force in B are the same. Then the ratio of increase in length, delta L of A whole divided by delta L of B has to be found out. So for this, what you need? Yes, the formula for delta L. How many of you do remember the formula of Young's modulus? Jaldi se with a smile tell me. What was the formula for Young's modulus? Yes, it is F, along with me, yeah, L, then divided by, right now by heart the formula and go from the class, divided by A delta L, है ना? Now rearrange कर ले, delta L is equal to F L divided by A by. So here as you can see, Young's modulus is same for both, force is same for both. So you can write delta L is proportional, as force and Young's modulus are same in both. We are not introducing in finding our ratio. So you can write delta L is proportional to what? L divided by area. Okay, देख ले, ऐसा होता है हमारा wire, right, where the end will be having a circular shape, right? So if that is having a circular shape, how will you find the area if diameter is given? अरे area of a circle pi d square by 4. कोई गड़बड़ नहीं है ना? No problem, right? So I'm going to write delta L is proportional to L divided by area of a wire, pi d square by 4. Pi r square, instead of radius we are using diameter, so pi d square by 4. Problem तो नहीं है ना? कुछ भी नहीं है. देख ले. Now we are going to find the ratio of delta L of A divided by delta L of B. So change in length is directly proportional to L, है ना? So देख ले, delta L of A is L of A divided by pi dA square the whole divided by 4. कोई problem? I have written the same formula over here. और कुछ नहीं. Then delta L of B, how will you write? L of B the whole divided by pi dB square the whole divided by 4. No problem still, I suppose. LA by LB, LA by LB, then dB square divided by dA square. So dB by dA the whole square. छोटू LA by LB क्या होता है? अरे LA by LB 1 by 2 it's given. dA by dB is 2 by 1. Here we have dB by dA मतलब inverse. So क्या हो जाएगा? 1 by 2 हो जाएगा with the square. हो गया. So 2 square is 4 into 2 is 8. So answer C मिल गया. How was the question? Question कैसा था वो बोल दे पहले. Question अच्छा था and उसके बाद बोल दे have you understood the concept by which we have done this problem? हाँ. Bye Palak, bye Palak. Yes. Okay, Desi, Shraddha, Jashan, Ethan, quite easy, very good. If you find it easy, फिर तो बढ़िया. Okay, so damn easy. अरे बाप रे, इतना easy था सबको. अरे बाप रे, then I'm so happy. Understood. Purna, Bhumika, Palak, Myara, Abhimanyu, Shraddha, got it. More questions, sir. Please, more questions. So everybody is like, sir, more questions. ठीक है. Let's see if the next question is from young Smodless or not. हाँ और क्या बिल्कुल almost of same concept. Swikriti, you are awesome. अरे thank you so much. Bhumika, which one is better? Me spending energy again and telling you the same thing, ठीक है? Or you just scrolling back, okay, from YouTube and listening to the same, मतलब ये सब recorded है. Which one is more better? You will just scroll back and listen to the same, है ना? करेगा ना और अच्छी और क्या? One more question दे दिया. If you tell me, obviously I have to do it, right? So tell me the answer. Tell me the answer. Jaldi, jaldi, jaldi. Anyone? It's a time for you all to do it. Last 15 seconds you all have. Miara is telling C. Ashutosh is like D. Then Abhimanyu with B. Jashan is with 8 with option C, right? Okay. Then Akshay is like with B. Preeti is like C. Okay. Shraddha with A. Monalisa with C. Desi. Okay. Preeti option is correct. So our correct option is C. Okay. I'll just explain you. Arpan is C. Akshay OP B बोल रहा है. So Sabra is with C, Akshay OP, then Palak. Okay, very good everyone. Let's read the question and understand this. वो करेगा हम पहले, ठीक है? देख ले. When a certain weight is suspended from a long uniform wire, right? Its length increases by 1 centimeter. Increase in length, मतलब delta L, that is given as 1 centimeter. Shall we make the equation first before we proceed with the questions? ठीक है. देख ले. Young's modulus का formula FL divided by A delta L. From here, rearrange and get the formula for delta L, that is FL divided by AY. So, the formula for increase in length is FL divided by AY. Okay. So, if the diameter of the wire is given, just now I have explained you how will you find the area, because wire will be having its circular base. है ना? So if diameter D is given, area will be pi D square by 4. I'm going to substitute the same and writing it here. FL divided by area is pi D square by 4y. ठीक है ना? Okay. In the first case, what is the increase in length given? 1 centimeter. Right? So that I have just substituted here as our first equation. ठीक है? Now, if the same weight is being suspended, if weight is same, the force that you are providing to that particular wire is also the same. It's suspended from another wire of same material. Material same है तो क्या same हो जाएगा? Young's modulus same. So I'll write it down. F is same here. Young's modulus is same. Why Young's modulus same? Because same material है हमारा साथ. right? And length is also same. Initial length है ना वो भी same है, but having diameter half of the first one, मतलब the new diameter d dash is half the initial diameter. Then the increase in length is the question, right? Find it. Delta L dash y dash, we are finding out the increase in length in the second case. Formula is F, same force, length, same length, divided by Young's modulus, same. Area is pi, right? D dash square by 4, pi by 4 into d dash square, because this is the new diameter d dash, and d dash is given as d by 2. So I'm writing it in a single step. So d by 2 the whole square. Why d by 2? Because the new diameter is half the initial value. ठीक है. 1 by 2 square क्या होता है? 1 by 4 है ना? ये 1 by 4 it will go to the numerator. So this will be 4 times FL divided by pi by 4 d square y. ये क्या होता है? FL by pi by 4 d square y. पता है क्या? अरे FL by pi d square by 4 into y है ना हमारा 1 सेंटीमीटर. So 4 into 1 सेंटीमीटर. This I am substituting it as 1 सेंटीमीटर. हमारा उत्तर हो गया 4 सेंटीमीटर. ऑप्शन सी. डन डना डन, उत्तर मिल गया, खुशी भी आ गया. Okay, clear. Really please. Next question. ठीक है. Okay, Purna giving the options. Very good. So you are a good typer also, Purna. Very good. You learned good. Very good, Purna. So proud of you. मिथिलेश, जशनदीप, क्लियर प्रीति. और क्या बिल्कुल. एक और क्वेश्चन करना है for sure, right? Let's see whether next question is from Young's modulus. हाँ, ये भी कर सकते हैं हमको, ये भी कर सकता है. मोर क्वेश्चन. और ये क्वेश्चन है ना हम नेक्स्ट मॉडुलस ऑफ रिजिडिटी के बाद हम करेगा. ओके, सो फर्स्ट वी लर्न अ छोटू सा कॉन्सेप्ट, उसके बाद हम नेक्स्ट क्वेश्चन करेगा, है ना. सो दैट थोड़ा कॉन्सेप्ट थोड़ा क्वेश्चन, थोड़ा कॉन्सेप्ट थोड़ा क्वेश्चन, दैट रेशियो विल बी मेंटेन्ड. व्हाट डू यू ऑल से? ओके, यो यस. बल्क मॉडुलस ऑफ इलास्टिसिटी व्हेन विल बी यूज? याद है that we are having a beaker with water. ठीक है, inside that you are keeping a big volume of material. Because of the pressure inside the water, what happens? Yes, the forces will be applied on all the points on this area, right? The body will be compressed, right? So here the stress developed, we call it, we have learned, we call it as, yes, the volume stress, है ना? Yes. And the strain developed here, we call it as volume strain, है ना? So इसका नाम है the ratio of volume stress to the volume strain. We call that modulus of elasticity with the name of bulk modulus of elasticity. क्या होता है वो रेशियो ना? वो होता है bulk modulus of elasticity. We use the letter B to express it. So volume stress divided by volume strain. Okay. Now वॉल्यूम स्ट्रेस का फॉर्मूला आई हैव टोल्ड यू, वो क्या था? प्रेशर, है ना? वॉल्यूम स्ट्रेस एंड प्रेशर आर द सेम. ठीक है. वॉल्यूम स्ट्रेन क्या होता है? डेल्टा वी बाई वी. अरे इधर नेगेटिव आ गया है सर, ये नेगेटिव क्यों? वाई देयर इज अ नेगेटिव साइन? ओके, आई विल टेल यू. देख ले, बिकॉज ऑफ द एक्सटर्नल प्रेशर इज अ वॉल्यूम इंक्रीजिंग और डिक्रीजिंग. वॉल्यूम इंक्रीज हो रहा है या डिक्रीज हो रहा है? वॉल्यूम डिक्रीज हो रहा है ना? Volume is decreasing. Yes or no? Yes. But tell me, what is delta V? Delta V मतलब final volume minus initial volume. If the volume is decreasing, delta V का साइन क्या होता है? V2 minus V1 का साइन क्या होता है? पॉजिटिव होता है या नेगेटिव होता है? अरे वो नेगेटिव होता है, isn't it? Because the volume is found to be decreasing. So V2 minus V1 नेगेटिव होता है. So here है ना, in the calculation of bulk modulus, as the volume is decreasing, delta V is found to be negative. In order to remove that negative sign, we will be adding one more negative, so that the term of bulk modulus will be given as positive. That's why either in the formula of bulk modulus हमारा साथ क्या है? Negative sign. Is it clear? Is it clear? Bulk modulus has to be positive. Very good, Purna. ठीक है, समझ में आ गया? समझ में आ गया? Yes. जशनदीप बाय ऑल, कहाँ जा रहे हैं आप हम सबको छोड़कर? ओके, रिटर्न, एवरीबडी रोट डाउन द फॉर्मूला ऑल्सो, ठीक है ना? ओके, सो अब हम क्या कर रहे हैं, वन मोर टॉपिक है रिलेटेड टू दिस, दैट इज कंप्रेसिबिलिटी। अरे सर ये कंप्रेसिबिलिटी क्या होता है, देख ले। द कंप्रेसिबिलिटी ऑफ अ बॉडी इज डिफाइंड एज, वेरी इंपॉर्टेंट, इट इज डिफाइंड एज 1 by inverse of bulk modulus. 1 by inverse of bulk modulus is given a new name and it is a new physical quantity, उसका नाम है compressibility. मतलब the inverse of bulk modulus will talk about how much compressible the body is. मतलब if the compressibility is more, the body will be more compressible. If the compressibility is less, it will be less compressible. That's what you mean. But how the inverse of bulk modulus, sir? Okay, ask me, sir, how the inverse of bulk modulus is acting as a compressibility? ये क्यों sir? Right? Why it is happening? Shall I explain you? देख ले, bulk modulus का formula just now I have told you, that is pressure divided by change in volume, fractional change in volume. So inverse of bulk modulus will be how much? 1 by bulk modulus, ये delta V by V ऊपर आ जाएगा when you take the inverse, right? Divided by pressure with a negative sign. So how are you going to explain this particular formula? Delta V by V is a fractional change in volume and at the bottom we have pressure. So if you give a definition for this, you can say, right, that is the fractional change in volume per unit pressure. Matlab, right, if you give 1 unit of pressure, how much fractional change in volume is happening? If this value is greater, okay, if this fractional change in volume per unit pressure is greater, what happens? Yes, the fractional change in volume will be larger. If the fractional change in volume per unit pressure is larger, what can you say? Obviously the body is more compressible. समझ में आ गया? That is the reason why the inverse of bulk modulus is given the name of compressibility. It talks about how compressible the material is. ठीक है? अंशिका, हाय सर, हाउ इज इट गोइंग? बिल्कुल अच्छे चल रहा है, बढ़िया चल रहा है. सो हैव यू ऑल रिटन डाउन एवरीबॉडी, बिकॉज वी आर गोना डू प्रॉब्लम्स. लेट्स डू सम प्रॉब्लम्स. लेट्स डू सम प्रॉब्लम्स. ओके, यस. अभी कौन सोएगा प्रीति? इट्स ओनली 8:54. Okay, yes, Shraddha, Myara, Sabra, okay, Arpan, okay, very good, Anshika, pure Punjab, and okay. मुझे बहुत सारे siblings, I have 3 younger sisters. Okay, now let's do some questions. Okay, questions करने पे क्या आ जाएगा? Energy आ जाएगा. Okay, here we go, देख ले. If the elastic limit of copper is 1.5 into 10 power 8 Newton per meter square. I hope you all do know, right? Which means it is the maximum value of stress till which the body will be acting in its elastic manner, right? Okay. Question A ki, determine the maximum diameter a copper wire can have under a load of 10 kilogram if its elastic limit should not be exceeded. Matlab, you are supposed to find out the diameter of a copper wire, right, if the stress does not want to be exceeded than 1.5 into 10 power 8. छोटू सा problem है. It's a very simple problem. कर ले अच्छे से. अरे Arpan already gave the answer. Jashandeep is like 1.02. Palak is like 1.02. जशन दी आपका आंसर 1.02 लॉक किया आप. ठीक है, और कोई ऑप्शंस है? ओके, यू डोंट नो हाउ टू सॉल्व दिस वन. मेरा, अरे दिस इज द सिंपल वन कंपेयर टू द अदर. ओके, सो एक्सप्लेन करना जरूरत है ना. सो लेट्स एक्सप्लेन दिस. सो यस, हियर वी गो. देख ले मेरा, चलो देख ले. It is given that the elastic limit, the maximum value of stress, so the body can have, so that the body will be in its elastic limit is कितना दे दिया? 1.5 into 10 power 8. ठीक है? So the maximum value of sigma the body can have is given with the formula of 1.5 into 10 power 8. Question ये कि right the diameter of the copper wire कितना होता है? Okay, so how can you express right sigma? Stress का formula क्या है? It is force divided by area, that is 1.5 into 10 power 8, isn't it? Force is it given? Array, it is given a load of 10 kilogram. What is the force given by 10 kilogram of a body? mg, right? Its weight. So the force is mg, that is 10 into g, that is 10 into 10 divided by, we know that all the wires will be having a circular base where the area will be pi d square by 4. वही सब्स्टिट्यूट कर ले इधर. सो एरिया का फॉर्मूला कितना हो गया मेरा बच्चा लोग? पाई डी स्क्वायर बाई 4, राइट? डन डन आर डन. नाउ यू all understood how the d can be found out. अरे just express sigma in terms of force by area, मिल गया उत्तर. So this is 1.5 into 10 power 8. Okay, then just rearrange, that's all it is. So 10 into 10 is 100, 10 power 8 is there. So from 10 power 8 this 10 power 2 is removed, what happens? 10 power 6, right? Okay, so this will be 1 divided by 1.5, I'm going to write as 3.2, 10 power 8 say 10 power 2 is being cancelled, so क्या हो जाए? 10 power 6 is remaining. Then cross multiply this to the right hand side, pi 3.14 t square the whole divided by 4. Okay, cross multiply कर ले फिर भी. Okay, this 4 into 2, 8 will go up, whole divided by 3 into 3.14. This 10 power 6 will be coming to the bottom. This is d square. Okay, take the square root. d will be 10 power 6 का square root हो जाएगा 10 power 3. 3 into 3.14, let us approximate. ठीक है, 3 into 3.14 का approximation, अरे उसका square root कितना? 3 3 are 9 almost, उसका square root 3 होता है. Okay, 8 का square root, what is square root of 8? That is 2 root 2, है ना? So root 2 is 1.4. So this is 1.4, 2.8. So कितना हो जाएगा बच्चा लोग? 2.8 divided by 3, it will be a value a bit lesser than 1. So almost let's say 0.9. This is 10 power minus 3 meters. So 0.9 into 10 power minus 3 meter कितना हो जाएगा? 0.9 millimeter. Is there any answer close to it? है हमारा पास ऑप्शन बी. मिल गया उत्तर? मिल गया तो मिल गया, आंसर भी मिल गया, समझ भी आ गया, समझ में आ गया ना? विद स्माइलिंग फेसेस. कहाँ है आपका स्माइल? अरे स्माइल कहाँ है बच्चा लोग आपका? Yes, the option B is correct. How many of you have given the option B? I forgot. कौन दे दिया था मुझे option B? I think very less number of people, right? सर 4 कहाँ से? किधर 4 कहाँ है? अरे एरिया इज पाई आर स्क्वायर और पाई डी स्क्वायर बाई 4. छोटू क्लासेस है, मुझे मिलना है क्या? अरे इतना छोटू कॉन्सेप्ट, एरिया का फॉर्मूला. ओके सबरा, numerical. Okay, just have you watched the method by which I have done the numerical? I say cut करके थोड़ा approximation करके we have done the problem. So did I take lot much of time in doing the numerical? Though it looks so bigger, right? Though there was point, बिल्कुल नहीं है ना? करचु क्या हो गया? करचु पे. अरे इस पे क्या हो गया? Sigma is force by area, force is given, area is given, substitute the values, just कट करके आंसर कर ले. इसमें इतना was a question tough मेरा बच्चा लोग? क्वेश्चन टफ था? टफ थोड़ी ना है, छोटू प्रॉब्लम था. अरे भूमिका पांडा अब क्यों रो रहा है? क्यों रो रहे आप? पूर्णा कॉर्चू मीन्स लिटिल. ओके, टफ प्लस इजी. अरे ऐसे कैसे हो सकता है? Okay, similar kind of question, right? those who found the previous question a bit tough है ना, by doing this particular problem you will be more and more clear about the concept. ये कर ले अच्छे से. I'll give you some amount of time, 1 minute ले ले आप सब लोग, read the question properly, right? Try to employ the method which we have employed in the previous question and try to get the answer. Okay, so let's see how many of you are going to give me the correct answer. अच्छे से. Let's see. हो गया? Shraddha is like A, Vivek is like a C. आंसर जल्दी मेरा चलो. ईदन बोल रहा है कि डी है सर. ठीक है, लेट्स सी. अरफन बोल रहा है कि बी है. म्यारा इज लाइक डी. अभिमन्यु इज लाइक डी. देन श्रद्धा ए, पलक सी, पूर्णा डी बोल रहा है, संकमित्रा डी बोल रहा है, मिथिलेश लवाल डी, अर्पन बी. सो गुड. एवरीबडी इज इम्प्रूविंग. देख ले. शैल आई एक्सप्लेन? Everybody listen here. अच्छे से we'll discuss this question in a very better way and understand the concept. देख ले मेरा अच्छा लोग अच्छे से. ठीक है, देख ले. Find the greatest length of steel wire that can hang vertically without breaking. Because if the stress that is developed in the steel becomes 8 into 10 power 10 or greater than that, the steel will break. That is what you mean by breaking stress. Breaking stress का मतलब क्या है? If the steel develop this much of stress or greater than that, ठीक है, that body will be breaking. So without breaking the steel, what is the maximum length of the steel wire that can hang? वही है question. Density दे दिया है. Okay, the value of G is also given. Let's understand the question in थोड़ा deep. देख ले. A wire, okay, what kind of wire it is? A steel wire, right? A steel wire, let's say of length area A and mass m is hanging ऐसे. ठीक है, it's hanging ऐसे. Now tell me, because of the mass it will be having a downward weight. mg होता है या नहीं होता? Yes, there will be. If there is a downward deforming force, we all know an equal amount of restoring force is also produced in that particular wire, isn't it? Yes. Tell me, if the length of the wire is increased, what happens? Yes, it becomes larger, right? The mass will become larger. मतलब if you use a bigger wire, length will be larger, mass will be larger, the downward force will be larger, okay, and the restoring force will also be larger. मतलब ये कि if the length increases, right, the restoring force increases, and if restoring force increases, the stress will also increase. ठीक है, length increases, stress increases, length increases, stress increases. So question ये कि what is the maximum value of length possible? So the maximum value of length that is possible can be found out from the equation of the maximum value of stress that can be produced inside the steel. So what is the maximum value of stress? We call it breaking stress. है ना? What is the value of it? 8 into 10 power 10. है या नहीं? है या नहीं? और क्या? हाँ बिल्कुल. Now tell me, what is the formula for stress? That is force divided by area. That should be 8 into 10 power 8. How much is the value of restoring force? Same as the amount of the weight of the body that is acting in the downward direction, right? So what is its value? Shall I write it here? Okay, so force is mg divided by a. अरे mass कुछ भी नहीं दे दिया इधर. So how can I express the mass as? Mass का formula density into volume. Is there anyone who doesn't know? सबको पता है, isn't it? Yes. So mass का formula ये होता है density into volume. मेरा बच्चा लोग so वही substitute कर ले. Mass is equal to density into volume into g the whole divided by a. I'm going to go with that equation series, though it is not supposed to write as such. So density क्या आता है? Rho itself. Volume of this wire, how will you write? If area is given, length is given, volume is area into length into g the whole divided by area. That is equal to कितना? 8 into 10 power 8, isn't it? Area क्या हो जाएगा? Cancel हो जाएगा. So from here you will get area is cancelled. Rho Lg is equal to 8 into 10 power 8. So L is equal to 8 into 10 power 8, the whole divided by density नीचे जाएगा. कितना है? 8 into 10 power 3, right? G will also go down to the right hand side as its denominator, that is 10 given. ठीक है, कैंसिल कर ले, 8 कैंसिल कर ले, 10 power 3 into 10, 10 power 4 by 10 power 8 हो जाएगा 10 power 4 with the unit of meter. सिंपल, मिल गया. The answer is 10 power 4 meter. कोई गड़बड़? थोड़ा भी गड़बड़ है क्या? थोड़ा भी नहीं है ना, थोड़ा भी नहीं. So clear? So here we have the correct option as D as our answer. Abhimanyu sir, why there is written 8.0? अरे क्यों? वो बता नहीं. We all have come to this particular session after attending the chapter of units and dimension. 8.0 is more precise, है ना? Isn't it? It has more. 8.0 is how many significant figures? 2, 8 and 0. Isn't it? For a value greater than 1, 0 to the right of a decimal is also counted as a significant. So if it has more significant figures, more is the precision of that particular thing. अब समझ में आ गया? Clear? Simple है ना? समझ में आ गया? समझ में आ गया? Just tell me, is it clear? With a beautiful smiling face. Yes. So how was the question? Was it good or normal? Yeah. Tough, easy? How do you rate the question as? How do you rate? Okay, कोई बात नहीं, लेका. Nobody has any opinion about the question. Good. Okay, so just a good. Okay, so I think it was a good question. ठीक है. So tell me, बच्चा लोग, how many modulus of elasticity we have discussed? What is Young's modulus we have discussed? Bulk modulus we have discussed. Along with while we were discussing bulk modulus, we also have discussed about compressibility, isn't it? Okay. अब क्या बाकी है? The third modulus of elasticity, which we call it by the name of modulus of rigidity. Okay. Now everybody can guess when will we call the modulus of elasticity as a rigidity modulus? Kab? Yes, whenever we talk about, yes, the stress as the shear stress divided by shear strain. That ratio of shear stress by shear strain, we call it by the name of rigidity modulus. Okay, yes. So shear stress, I hope you do all remember, है ना? ये shear stress का. अरे देख ले, if you are having a cube like this, okay, if you are having a cube like this, ऐसे, I'm just converting this into a cube. And if you are applying a force, ऐसे देख ले, if you are applying a force parallel to the surface, what happens? The body will be making an inclination. Yes or no? So the stress produced in that case is shear stress. The strain produced is, we call it by the shear strain. Uska ratio है rigidity modulus. Formula. Shear stress का formula F by A. Shear strain का formula. How many of you do remember the formula of shear strain? वो बोल दे. Shear strain का formula और चलो. How many of you do remember? देख ले. If you know x क्या होता है? How much distance the upper length have moved, वो होता है x, right? Okay. And if you know this particular length also, shear strain is given by x divided by L, isn't it? So G, rigidity modulus is F by A divided by x by L, one formula. F by A, the whole divided by, if you know this theta, what is x by L in relation with theta? X by L क्या होता है? That is tan theta, isn't it? So rigidity modulus, another formula is F by A divided by tan theta. If theta is very small, You know that tan theta can be approximated to theta. So another formula for rigidity modulus is F by A whole divided by theta. So according to the question given, right, you can use either of these particular formulas and find the unknown here. Okay, मेरा बच्चा लोग, can I have that smile? Can I have that smile back on your faces? Shruti, I'm your biggest fan. Arey baapre, I have the biggest fan in the class. Good, Shruti. Good to have you here. Clear? Got it, Miara? Okay, so Ethan is like, sir, rest for tomorrow. So you want to continue in tomorrow's class with Poisson's ratio? आज चाहिए या कल चाहिए? आप ही बोल दें. सर स्माइल नहीं आती है क्यों? The life has to be with full of smile and happiness है ना, so the smile has to come. Tomorrow, today, tomorrow. I have a mix of options here, right? So I think we'll continue in tomorrow's class. We have enough time. 4 classes है, so I think only छोटू topics बाकी है. So I think we'll give it for tomorrow. What do you all say? We'll keep the energy, the Poisson's ratio, okay, applications of this elastic in tomorrow's class. We'll do lot many questions also. So it's going to be super amazing. Exhaust हो गया 100%. Okay, I think it was a huge theoretical class है ना. We were doing lot of theory. तो हो सकता है. Menti, इस chapter का Menti Friday हो रहा है. So be prepared everyone. Everyone be prepared. Okay. So happy? Okay. Now we'll be continuing with the remaining topics in tomorrow's class. मेरा बच्चा लोग. Okay, special class तो हो गया. Now, बच्चा लोग, tell me, right? How many are here who haven't shown some love towards Ameer sir? जल्दी से जल्दी जाकर click on that like button and do let me know that you have enjoyed the class. जल्दी फटाफट से, right? Okay. At the same time, these are the other batches that has started. You can also come and be a part of it. Okay. So science batch, commerce batch, humanities batch, right? So many batches are there. Whichever you want to, you can come and be a part of it. Right? Okay. So free special class ka features. How to join a quiz? You all know that. There. Song kal. Tomorrow pakka. Okay. Friday is the day for songs, right? So tomorrow I'll be singing songs for you all. Okay. So yes, those who haven't subscribed, you all can subscribe to the channel. क्यों करने subscription, so that you will get the notifications from this particular YouTube channel. मतलब whenever a teacher is going live or anything. ठीक है? So make sure that before you leave, you subscribe to the channel, click on the bell icon. So like and share. Bye everyone. Thank you so much. See you all tomorrow. Thank you so much, Miara. Thank you so much. So Aditya, Bhumika, Palak, good night everyone. See you all in the next class at 8 p.m. Don't forget. Okay, tomorrow should be there, right? Beautiful song. Tomorrow we'll be having a beautiful song also. Okay, so bye bye everyone. Take care.